So the presentation has to be started, or is it ending of this session?
Sir, within 5 minutes, we will go for question answer session, sir.
Yeah, okay. You can start the
Sir,
question.
if there is anything else left,
Yeah, I can show you. So I'm sharing my screen.
sir, then if the presentation is ended, then we will go for question answer session. Will we, sir?
Should I present now?
Yes, sir. Yes, sir.
Okay, so simple, we have one of the complete controller and PID and complete controller with ANN based solar PV, MPPT control and PWM control. Just let it open. Is it visual? My screen?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So here we have this data, this complete simulation. In this complete simulation, we have solar system connected here. You can see here, this is blocking diode. Reverse current cannot go into the solar system. We have the measurement of the VPV, IPV, and power of the PV. So it is instantaneous value. We have inductor here. We are using the boost converter, and one of the PWM signal is being coming to here to control the system, the solar to the maximum power point. And this is diode. This is the capacitor or the DC link connected to the inverter of the BLDC motor. Here we have the battery energy storage system. Battery energy storage system has three main parameters: current of the battery, voltage of the battery, and state of charge. So battery should, in standard case, should not go below the certain state of charge limit, and it should not exceed 90, not exceed about 200. So it should be within the some margin so that its life is better. We have to design this battery system with the required capacity of the motor. Suppose we have the EV which has the 20 Newton meter torque at its rated capacity, and it operates at certain RPM, 3000 RPM, as in the car's parameters, some Newton meter and RPM is given. So we can check what are the ratings required for that capacity of car. So equivalent motor can be selected. So based on that if our motor is continuously taking the rated voltage and it is continuously taking the rated current, then its capacity should be, the battery's capacity should be such that it can provide that much current for uh, that time. Suppose we are driving a car for 3 hours and we had continuous 10 ampere rating or 20 ampere rating of the motor, and for 3 hours we need the 3 into 20 amperes. So the thumb rule is simply we can determine that our capacity of the battery should be such that it can drive at fully charged condition. It should drive 3 hours with the rated load capacity and rated speed. Okay, so we can define the battery capacity here. Here we have the nominal capacity and the nominal rated ampere hour of the battery. We have the initial state of charge. It should not go very low and it should also not rise to 100. So it should be kept within the some range. So when it is charged to high value, it should be discharged and charging should be stopped. And when it is under certain level, it should not be used. It should be charged only. So effective battery life, increase in the effective battery life is ultimate efficiency of the system. So we have also to assure the temperature of the battery. We should not limit the, we should not increase the charging current. So for the when battery voltage is very low and the SOC is very low, whenever we give the voltage or charging, the charging current can increase very high. So during the uh, initial charging, we need a constant current charging, and when there is sufficient voltage, certain voltage level achieved, and which is stable, then we charge the constant voltage charging for the battery. So here MPPT will only be possible when we have, apart from the load, we have a storage system which can store the energy during lower loads. Without the storage system, our MPPT will not work. Okay, in grid system, the MPPT will work without the storage system, because on grid mode, the whatever the energy the load is taking, uh, the system will be led to such that the PV generates maximum power and feeds extra power than load to the uh, grid. So in on-grid mode, we do not need the storage system. In off-grid mode, we need the storage system so that we can store the energy for future use. During the lower loads, also the SOC will increase, and during the heavy loads and during the uh, uh, lower irradiance or energy generation, the higher SOC drop will be there, and higher lower will be the voltage. Okay, so here we have the boost converter. Boost converter is used for uh, ensuring the higher energy storage, ensuring the higher energy storage in the battery. So solar PV has these parameters we can see by clicking. We have maximum power for a particular, suppose we have three parallel strings, three parallel PVs modules in string, and uh, 15 series connected modules. Then in series connection, the voltage will be multiplied, and in parallel connection, the current will be multiplied. In this way, our overall the power will be multiplied by the total number of cells in whole array, modules in the whole array. Like here we have the 15 parallel and 3 parallel and 15 series modules. So 15 into 3, that is 45 total modules will be there. And in this case, if one module has 213 volt watt of the power, then the total power will be multiplied with total power of the array will be equal to 45 multiplied by 213. So it will be approximately 10,000. And the 36 is the open circuit voltage. In series case, the 15 will be multiplied to this 36. So overall voltage will be 36 multiplied by 215. Okay. And peak voltage will also be multiplied by 15 in the array. And when we are talking about the ISC, so ISC will be multiplied by 3 for whole array, because one module has 7.84. So the overall short circuit current of the whole array will be 7.84 multiplied by 3. And current at maximum power point, overall current of the array at maximum power point will be 7.35 multiplied by 3. So we can understand from here how the arrays and individual modules are working. Here we can check the irradiance and temperature graphs of this whole module. Whatever module we have selected, this system draws the PV and IV characteristics of the system. Based on this, we have noted some values here. What is the value of voltage and what is the value of current? We can collect the information from here. Like here 435 is the voltage, 9592 is the power, and here 434.5 is the voltage, and 8661 is the power at 900 watt per meter square irradiance. So as much as the irradiance is reducing, we have lower the power output in the system. Okay, so this whole data is taken and noted by me, and now I will show you how to design the ANN based MPPT control algorithm. Am I audible?
Yes, sir. Sir, sorry for the interruption. Maybe, sir, we have to go for the question answer session. If you
Okay,
allow
okay,
us, and
okay, okay. Thank you.
okay. Sir, again, thank you very much for such an engaging and insightful session. So you delight explanation of control strategies in BLDC motors with integration of solar PV and BESS has added great value to our understanding. So without any further delay, now we have some question answer session. If anyone have any question, feel free to unmute yourself and ask directly.
I have a question about that. How does the battery systems help in controlling the BLDC motor when the solar power changes, sir?
Yes.
Sir, how does the battery systems helps in controlling the BLDC motor when the
Yes.
solar power changes, sir?
Yes, when solar power deficiency is there, your battery will provide the excessive power to the required load demand in the BLDC motor. Okay, so whenever we have we design the solar system such that during the operation, how much time we want to operate the system, and for how much time we have the unavailability of the solar system energy. So suppose we have the motor of 480 watt. Suppose we have the motor of 480 watt, and for continuous 48 volt, at rated 48 volt, it takes 10 ampere, suppose. Okay, so if we want to operate this motor at 3 ampere, 10 ampere rated capacity continuously for 3 hours, then our battery capacity should be 3 into 10, that is 30 ampere hour. Okay, so battery capacity is defined. Now our energy should be such that it should also be provided during the off solar time. So whatever the energy during the daytime or during sunshine we have collected, it should be provided for. Suppose we want to operate our system for 24 hours, like pumping. We want to operate our system for 24 hours, and we have 480 watt of motor, suppose, for example, 480 watt of. So our power required is 48 volt multiplied by 10 ampere. Okay, so 480 watt power is required for 24 hours. So during the whole day, only 6 hours or 5 hours we have total energy generation, and this total energy generation should be sufficient to provide whole of the 24 hours for 80 watt. So for this we multiply it at least 4 times. So 480 watt should be the 480 watt is the motor power. So our solar power should be multiplied by 4. Okay, so approximately it should be 2000 watt should be the solar power. So during the daytime, it will additionally charge the battery, because our power will be totally generated during the whole day. So partial power will be stored in the battery, and partial power will be utilized in the load, and remaining 18 hours, this battery whatever is stored, the battery stored the power energy that will provide the energy to the load during the off solar system time. Okay, so this battery plays a very important role during the designing of the solar based BLDC motor based pumping or BLDC motor based EV system.
Okay, sir. Thank you, sir.
Anyone have any other question?
Yes, sir, I have. Sir, in the starter, we have used 3 Hall sensor and
Yes.
120-degree apart. If we use it, use more Hall sensor in the degree of 90 or 60-degree apart, it will be efficient or it will be disadvantage for our control system.
Okay, generally, as I have demonstrated you in this complete lecture, that when the rotor is at 100, it will operate A plus and C minus. But when the 100 comes, actually when we operate the any flux at 60-degree, there will be not much torque as compared to when we operate at 90-degree. So when the rotor is aligned at particular direction, then operating the particular phases at 90-degree will be more beneficial, because it will regulate the current spikes more. Okay, so what we do are this: we actually not fit the Hall sensor chips below exactly the phase axis. If we shift 30-degree anti 30-degree before the phase sequence, means if we have phase sequence clockwise, then we shift the Hall sensor 30-degree before that. Okay, so in that case, what will happen? Whenever the rotor reaches 100, the A plus and C minus combined flux will be exactly at 90-degree at that time. Okay, so shifting, it is actually the Hall sensor shifting will be actually compared to the brush shifting in the normal DC motor. If we shift the brush, there is some improvement in torque and RPM. Okay, So in the same manner, it also works. If we are working in opposite direction, we are rotating the BLDC motor in opposite direction, then the reverse logic should be different. Okay. So in BLDC motors, we have forward logic and reverse logic. In case of 90-degree phase energization from the rotor position, there is no difference, means there is no difference between the torque in positive direction or torque in the negative direction when we use the positive or negative logics. So 90-degree is more beneficial. So we should design the motor, and actually motor comes with the 30-degree displaced Hall sensor chips. They are not exactly below the phase A axis. Hall sensor will be 30-degree displaced for making the rotor and flux 90-degree. Maximum torque will be there.
Thank you, sir.
Anyone have any other question? I think maybe all have understand already the discussion, sir. So, sir, we should wrap up then. So, as we wrapped up today's event, I would once again like to extend our heartfelt gratitude for our sir, Dr. Umesh Kumar Soni, for his time and valuable information, and also Dr. Khadija Akhtar Bonna for her constant support and presence, and to all of you to engage and enthusiastic audience. On behalf of the IUBAT student branch, this is Mohammad Abu Haider Shumon signing off with warm thanks and best wishes. Let's continue to explore, innovate, and inspire through knowledge. Thank you. Have a wonderful evening. Sir, we may finish our today's session.
Thank you, sir. I really appreciated all of your presence and all of your active support and your interest in my lecture. And I thank Dr. Khadija Akhtar and inviting me for this expert lecture. I thanks once again.
Sir, one question, one request on behalf of my student.
Thank you so much,
Am I
sir.
audible?
Ma'am, continue, please.
Our presenter, sir, is still available with us.
Yes.
Sir,
Yes.
one request on behalf of my student. I mean, our student. Is it possible for you to provide us the PowerPoint have already discussed today?
PPT?
The PowerPoint, yeah, the presentation slides.
No, actually, this PPT is most of the part is from my PhD. So actually, it will be hard to remaining. I will be always be there for support and guidance.
Okay, sir.
Whenever anyone wants my help, I can provide him directly on line or whatever way. I can provide him the guidance in case of requirement.
Okay, sir. Thank you once again for giving us your valuable time, valuable speech. So hopefully we will be connected with you again with other sessions.
Definitely, I will be supporting the IEEE IUBAT.
Yes, sir. We can end our session, I guess, or moderator can end our session.
Okay. Thank you, ma'am. Thank you everyone for joining with us today. It was a remarkable, I will say, achievement for us to acknowledge all those things. So thank you once again, sir, for your valuable time and information. We may close our session here for today.
Thank you. I leave now. Thank you.
Thank you, sir.